Find the directional derivative of the function f, which is equal to 2 into e to the power 2x minus y plus z at the point 1, 3, 1 in the direction towards the point 2, 1, 3. So we have to find out the directional derivative of the given function in the direction towards the point this. From this to this means we have to find out the vector. Suppose a vector which is directed from the point 2, 1, 3 to the point 1, 3, 1. So here the point, suppose this point is your x2, y2, z2, and this point is x1, y1, z1. So the vector representing from the point 2, 1, 3 to the point 1, 3, 2, 1, 3, 1 will be equal to a vector, which is equal to, use this formula, that is the distance between 2 points x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Using this relation you can find out the vector. Suppose a vector is equal to 2 minus 1 into I cap plus 1 minus 3 into j cap plus 3 minus 1 into k cap. So this will be equal to 2 minus 1, 1, so I cap 1 minus 3, that is equal to minus 2. So minus 2 into j cap plus 3 minus 1, so 2 into k cap. So this is the direction towards which you have to find out the directional derivative of the function f. So the given function f is equal to 2 into e to the power 2x minus y plus z, and to find the directional derivative of the function f in the direction a, you will use the formula gradient of the function, dot product of gradient of the function with the unit vector along the direction of this vector, suppose a. And we know unit vector along a vector, suppose a, is equal to vector a divided by magnitude of vector a, and gradient of a scalar function, this function is a scalar function. Gradient of a scalar function can be represented in terms of del operator, that is del of f, where del is a vector operator which operates on the scalar, that will give you gradient. We have discussed about gradient in the previous video. So del of f dot vector a divided by magnitude of vector a. Now let us solve this problem. So to find the del of a scalar function, the del operator we know is given by I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z of the scalar function. The given function is 2 into e to the power 2x minus y plus z, and this will be dotted with the unit vector, and here unit vector is equal to vector a, that is we have found out I cap minus 2j cap plus 2k cap divided by magnitude of vector a, that is 1 square plus minus 2 square plus 2 square square root. So if you take the partial derivative of this function 2 into e to the power 2x minus y plus z with respect to x, then that will be equal to e to the power 2x minus y plus z, because derivative of e to the power x is equal to e to the power x. So here derivative of e to the power 2x minus y plus z with respect to x will be equal to e to the power 2x minus y plus z and a derivative of 2x, that is equal to 2 into 2. So 2 into e to the power this much, again this 2 is a constant, so here you have a 2, and this 2 is the derivative of this function 2x. Similarly, you can find out the derivative of this function with respect to y, that will be equal to 2 into e to the power 2x minus y plus z, and derivative of minus y with respect to y is equal to minus 1 j cap. Similarly, for the k cap component, if you find out the partial derivative with respect to z, this will be equal to 2 into e to the power 2x minus y plus z into k cap, because here there is z, so partial derivative of z with respect to z is equal to 1, so it is multiplied with k cap. in the numerator of the vector I cap minus 2j cap plus 2k cap, it will remain as it is, and if you solve it, this will be 1 square plus 2 square minus 2 square is equal to 4 plus 2 square, that is equal to 4. So 4 plus 1 that is equal to 9. So square root of 9. And in the numerator, if you take common 2 into e to the power 2x minus y plus z, then in the bracket you have 2I cap minus j cap plus k cap, and dotted with I cap minus 2j cap plus 2k cap, square root of 9 is equal to 3. So if you solve it, that means we have to find out the directional derivative of the function, given scalar function, at the point 1, 3, 1. So to find the directional derivative of the function f along the direction a at the point 1, 3, 1, we will put x value is equal to 1, y value is equal to 3, and z value is equal to 1. So if you put x is equal to 1 here, this will be equal to 2 into e to the power 2 into 1 minus y value 3, so minus 3, plus z value is equal to 1, so plus 1, multiplied by 2I cap minus j cap plus k cap, dotted with I cap minus 2j cap plus 2k cap divided by 3. So this will be e to the power 0, because 2 minus 3 plus 1, this will be equal to 0. So e to the power 0 is equal to 1. So only you have 2 multiplied by this vector, that is 4I cap minus 2j cap plus k cap, 2k cap. This one dotted with I cap minus 2j cap plus 2k cap. So if you take the dot product, then you have I cap dot I cap is equal to 1. So 4 minus j cap, that is equal to 1, and 2 multiplied by 2 is equal to 4. K cap dot k cap is equal to 1. 2 multiplied by 2, that will be equal to 4. So in the numerator you have 4 plus 4 plus 4, 12 divided by 3, so that will be equal to 4. So in this way you can find out the directional derivative of a given function at a given point in the direction towards another point.